Hello, everyone. You are welcome to my online mathematics class. The topic before us today is sequence. What is sequence? What is sequence all about? Sequence have to do with the arrangement of a number according to a particular order, according to a particular rule, according to a particular pattern. You don't just arrange number anyhow. You arrange the number based on a particular law. For instance, I may have one, two, three, four. These have to do with the arrangement of number. I can ask you to find the 1000 term of this number, then you'll be able to find it. Another example of a sequence is when you have one, I can have four, I can have nine, I can have 16, dot, dot, dot. From this question, I can also ask you to find the 20th term. If I ask you to find the 20th term, you should be able to get it. Note very well that the first number is always your first term. The second number is always your second term. The third is your third term. The fourth is the fourth term. Then sequence can be divided into two. We have the type of sequence. We have the first one, AP. The AP is an abbreviation and it means arithmetic progression. Under this arithmetic progression, it has to do with the arrangement of numbers too. It has to do with the arrangement of number in which the difference between the consecutive terms are constant. Arithmetic progression have to do with difference. For instance, I may have some numbers here. I may have one, I may have two, four, six, eight, dot dot dot. If you have this number, the first time, if you look at the first term and the second term, the difference between them is 4 minus 2, that is 2. The difference between the third and the second, 6 minus 4, that is 2. 8 minus 6, that is 2. You will notice that that difference is constant all through. So anytime you are talking about arithmetic progression, you have to consider the difference. And the difference is always given by the second term minus the first term. So in arithmetic progression, common difference is always essential. Then under this arithmetic progression, question can be asked in two ways. The question to be asked either be given in terms of nth term, or it can be asked in terms of the sum. What I'm trying to say in essence is that under arithmetic progression, question can be asked in two ways: nth term formula and the sum question. Under the nth term, there is a formula that can be used to solve question under nth term of an AP, and that formula is given by UN or Tn is equal to A plus N minus 1D, where your UN is always the nth term slash last term. It can be the nth term, it can also be the last term, as in the UN. Then you have the N. The N is the number of terms. Anytime you are solving a question on AP and you have a number and TH, that should be your N term. Then you have the D. The D is the common difference, which we have talked about earlier. You have the UN, and the A is the first term. So under nth term, this is the formula that you can use to solve any question under nth term. Then when you now consider the sum, whenever you are solving a question on AP and you are asked to find the sum, you are going to use the sum formula. Sum formula in AP is divided into two. We have the first one. Sn is equal to n all over 2 into 2a plus n minus 1 d. And we have the second one. Sn is equal to n all over 2 into a plus l. It depends on the information from the question. The information from the question will determine the formula you are going to use. For instance, if you are asked to find the sum formula and you are given the first term and the last term, and the number of terms is also given, of course you are going to use the second one. But if you are asked to find the sum of the nth term, you are given the n, you are given the a, and you are not giving d, or you are also giving d, you are going to use the first one. So that is that on AP. Then the second type of sequence is GP. GP as in geometrical progression. Geometrical progression. The GP too have to do with the arrangement of numbers according to a particular pattern in which the common ratio of the consecutive terms are constant, are the same. What you have to notice is that AP have to do with AP have to do with difference, while GP has to do with common ratio, which is division. For instance, I may have 2, 4, 8, 16, and I ask you to find the next. If you look at this, you will notice that we cannot find the difference of this. If you try to find the difference will not be the same. Like for instance, I may have 4 minus 2. 4 minus 2 will obviously give us 2. 8 minus 4 will give us 4. 16 minus 8 will give us 8. So you can see that it is not the same. But we are talking about common ratio. We are talking about something that should be constant all through. So when you are considering GP, when you are under GP, when you are solving questions under GP, you are going to find common ratio. And the common ratio, which is given by half, is equal to the second term divided by the first term, as in 4 all over 2, 8 all over 4, 16 all over 8. 4 over 2 will give us 2, 8 divided by 4 will give us 2, 16 divided by 8 will give us 2. So it must be uniform all through. Hope I'm making sense. That means the common ratio now you can see is constant. So GP can be defined again as the arrangement of numbers in which the common ratio of the consecutive terms are constant. And like under AP, we consider n term AP. You can solve question under AP under under two laws, as in n term and sum. The same thing applies to GP too. You can also solve question under GP by considering the n term. The n term for a GP un is given by AR n minus 1, where the A is the first term, the R is the common ratio, the un is the nth term or the last term. Then you can be asked to solve a question. Why? The formula for the sum of a GP, we have Sn is equal to A into Rn minus 1 all over R minus 1. Then Sn again is equal to A into 1 minus Rn all over 1 minus R. You can see that the sum difference, the sum formula for a GP2 is divided into 2. This is the first one. You can use the first one when R is greater than 1. And the second one can be used when R is less than 1. Then we also have another formula under GP, which is sum. We call that one sum to infinity. Sum to infinity. That one is always S infinity is equal to A 1 1 minus r. These are the formulas that can be used. These are the formulae that can be used to solve questions under AP and GP. With this, we have come to the end of this particular episode. In our subsequent episode, we will be solving questions on both AP and GP. Happy viewing. God bless you. God bless you. Take care.